After office hours comes innovation. After office hours comes excellence. After office hours comes a new generation of Salesforce AI trailblazers. Welcome to the After Office Hours 5-day Agentforce intensive training. From 01 to 05 December 2025, 7 p.m. to 8:30 p.m. Iced. Powered by SalesforceUserGroup channel. Massive shout out to our co-host leaders across India. Thank you, Trailblazers, for uniting this community. Together, we learn. Together, we lead. After office hours, we ignite the force. Agentforce rising, we're the future source. Trailblazing mind, we break down the doors. Learn AI. LLM foundations, transformers, attention, generation begins! On a day 2, prompt engineering, talk with AI like a boss, precise and winning! On a day 3, Agentforce, agents, topics, actions, instructions, automate the magic, Agentforce actions, flows, apex, services, superpowers unlocked. Day 5, the grand Agentforce demo. Service marketing, ask me anything. Full excellence mode, activate after office hours.
I would like to thank everyone present here and for taking your time to attend this. And as said, we've iterated this multiple times, but this is day 1 of after office hours, and the theme for this entire session or the sessions from day 1 to day 5 is more about understanding what is AI and what are large language models and Agentforce. Okay, so for today we'll talk more about AI, and we'll touch base on what are large language models, what are the different models that are available right now. Maybe just want to give you or throw you of what are the different models that are currently in play apart from the large language models. I think many of you would have information about what is large language model all about, but not sure whether what is the architecture, how does it actually work. Maybe if you give some prompt, it brings you or generates some response, but do you know how it actually works? So this session will focus more today on understanding how it works and the other nuances as well. Okay, so yeah, to start with, I'll give a quick note from our perspective, from speaker's perspective. And since the weather condition is very bad in Chennai and other parts of Tamil Nadu, I thank everyone for attending this session. And this office hour sessions is specifically designed for audience who have prior knowledge in Salesforce and have basic understanding of what AI is and what it does. Okay, and this session is actually a continuous session from day 1 to day 5. So not attending or missing out any one of the session could lead you to missing out the entire context for the next session. So please refrain from doing that. And we'll cover, or at least we'll try to cover, theoretical information from basic to intermediate about each and every topic that we talk about. Okay, yeah, the third point is more towards, and we'll cover the theoretical information as said, but it may not lead you to build an entire agent ecosystem from end to end. Okay, we'll provide you sufficient information of what to learn, what to look at, what sort of information that you have to find out. But in terms of practicality, you have to go into the system, create a demo org, understand how agents work. We'll provide all of the theoretical information, but the practicality is up to you. Okay, and the fourth point is The information that we derived, we obtained is as of October 2025. So any future information that is available right now may not be present in the content. So just a caution over there. And as said, these sessions will be recorded and uploaded in the YouTube later. Okay, so for future reference. Yeah, we will quickly move on. And I want to talk about the agenda for today. So we'll touch base on like what is artificial intelligence, how does an AI work actually, what are the different components within it, what are the subsets in AI, artificial intelligence, introduction to large language model and its importance, traditional machine learning models, types of XLM. So these this is the concept that I wanted to bring in, because apart from large language models, what are the other models that are in play right now? And in a large language model, you often hear something called transformer architecture. So this is actually the backbone, or like how it actually works. And you have tokenization, attention mechanisms, and sampling techniques for text generation, more towards on a generative AI. Okay, so I'll take a minute or so. From your perspective, what do you think artificial intelligence is all about? Maybe you can use your chat and give me some response. We'll make this more interactive. Maybe from each one, like it might be a different perspective, but I can I can contemplate it like one single definition for you. So everyone thinks in the same perspective. So artificial intelligence is nothing but it can help a system to simulate a human thinking, maybe a human intelligence in a machine, think in that way. Okay, so how do we think, how do we make a decision, how do we interpret any problem and perform certain actions? Through artificial intelligence, what we do is we provide the power to a system so that it can learn, it can adapt to any ecosystem, and also it can perform complex decision making as well based on the data sets that we provide. And that's what AI is all about. But in terms of AI working, like what do you know about how does it actually work in the background, right? So as you see in the screen, there are stages, like 4 stages, in which like you always have the data input. So through which like you can train a model, or this is actually the key where you can uh, provide large sets of data for your system to process and understand and make it more viable and also usable. Okay, next comes your processing system. So here the processing system uses different algorithms. So that's what we are going to talk about today. So all the models that we are going to discuss today, and also the main one, the large language model, algorithm or the processing system is the key, where when you get a sufficient amount of information, you need something to do to that data in order to get some information. So that's what processing is all about, right? So you identify patterns, you identify features, you identify similar structures, right? So those sorts of algorithm will be in your processing system. Okay, then you have outcome. Say for example, you talk with an AI system, you need something, so it should have some sort of a result or an outcome, right? It can be positive, it can be negative, or it can be neutral, anything, right? So once you have that result, that information is fed back into the processing system. Say for example, if you have someone that says, hey, the result is not right, or if the result is right, those sorts of feedback have to be fed into your system or the processing system. So that's where the feedback loop comes in. So these sorts of continuous learning would help an AI system to be better, to make decisions better. Okay, so and also this is the entire holistic flow. There are like multiple in-depth concepts to each of the stages that you see here. We'll touch base one by one going forward. Okay, so here we've termed it as components of an artificial intelligence, but we can also say it as an evolution. So starting, you might have heard artificial intelligence, but some of you might also heard machine learning. There are multiple concepts to machine learning, where you have something called deep learning, you have predictive analytics or predictive AI. Then comes your natural language processing, where any human readable text can be understood by an AI system. So based on the information that is provided by a human, instead of massaging anything, you directly provide a raw input that comes out of your mind. So AI system understands this. That's capability where you have this language processing or like natural language processing. You use classification or translation or data extraction as a concepts. Then comes speech. Instead of providing text, you can provide speech to AI where it in turn turns it into a text, and from text to machine readable formats such as vectors. Then you have expert systems. You have an entire agent which creates an agent plan. So an agent plan would also have your step-by-step approach of what to take, what is the first step, what is the last step, and so on and so forth. And after that, you have vision systems right now. Vision systems like pretty much common. Everyone have it in your mobile, like using Face ID or something where it can recognize your image. But how does it actually do it? It turns your image into vectors that are readable by any machine, and also it can generate an entire context or an environment based on the information that you. Next, you have robotics, a complete autonomous systems, which are currently the pinnacle of an AI system, right? Okay. So we've talked about artificial intelligence, but I want to go a little deeper and talk about like touch base different concepts within artificial intelligence. We all know that artificial intelligence has machine learning, but apart from machine learning, we have these concepts like rule-based systems, symbolic AI, expert systems, and traditional NLP. We've talked about expert systems and traditional NLP in the previous slides, but rule-based systems are nothing but a simplistic chatbot. I think many of you might have come across in your customer, in any of the customer service website. Maybe if you want something, you go to the chatbot and you ask for any certain information. Not right now, but previous years, like it has predefined sets of rules. Any input that you provide, it looks for a certain keyword or certain sentence. Based on that, it predicts or it routes to the exact next steps. It only has a certain predefined set of configs. You cannot change it. Rather, you can change it in the backend, but it cannot predict or it cannot understand the human context. Next comes your symbolic AI. Symbolic AI, nothing but based on the name suggests an AI system that can understand symbols rather than text or any human readable formats like an image or so. Maybe take an example where you have a chessboard. Okay. When you train a AI system to understand the entire chessboard, it knows the chess piece, the move that the chess piece can make, and the opponent of like what they can do, what sort of prediction they can do. So that's a controlled environment. Apart from the chessboard, a symbolic AI system cannot do anything or like cannot perform anything outside of it. So that's the limitation that it has. And expert systems are nothing but your chatbot that is powered using a knowledge base. Maybe an expert system can be your knowledge base. Anything that you ask a chatbot, it reaches out to your knowledge base, get relevant information such as links or any sort of blogs, and it comes back and provides that information. It does not think enough, or like it does not know like what to say. Rather, it reaches out to the expert system to get some additional information. Apart from machine learning, these are the concepts within artificial intelligence. Similarly, apart from deep learning, in machine learning, we have like multiple concepts. I think many of you might have come across supervised learning and unsupervised learning. So as name suggests, supervised learning is nothing but you have a human or a supervisor in place in a model or in order to train a model. So when the model learns, it uses labeled data, right? So labeled data, it uses uh, the data as a reference, and based on that, when you provide additional input, it uses that reference and compares it and groups it accordingly. So that's a basic supervised learning that we have. Some of the concepts are like decision trees, random forests, support vector machines. Say for example, you train a model to identify a fruit. Okay. So in a labeled data, you provide a fruit, the feature of a fruit, like it should be round, it should have a red color, right? And it should have a kind of a leaf at the top. Okay, these are some of the reference information. And you also have an additional labeled data where you say another fruit would have a long body, it would have yellow in color, and there would be some of black patches. So you term it as banana. Okay, so the next time when you provide additional information or additional input saying you provide an apple, it does not ask for like what sort of features it has. Rather, with the reference information that it has, it depicts that it's an apple instead of banana, because you already trained that model to say there's a reference information. Use that information to predict the outcome or to predict what is it all about. Similarly, unsupervised learning, as the name suggests, you don't have any supervisor in place. Rather, you leave the AI system to learn on its own. Rather, you provide a reference or a label data. The input that you provide, it uses that information to predict or group based on certain features. So instead of you providing all of the information before in order to identify a fruit, right? Automatically what it does is like, okay, it's round and it's red, it groups it separately. If it's long and it's yellow, it's groups it separately. Next time you add another input to it, it basically looks for red color and round, or it looks for long body and yellow. So that's what it actually does. You do not have any supervision in place. Rather, you ask the machine to learn on its own. The advantage here is here you have a clear vision of like what to do and what not to do, but there would be some hidden learnings as well in unsupervised learning. So that's the advantage that we see here. Okay, in machine learning we have supervised, unsupervised, and also deep learning. But when we deep dive in further in deep learning, we have other few concepts like generative AI, where like most are like interested all about currently you're using, right? And predictive AI, and your image recognition, recommendation systems, and autonomous systems. So I'll touch base on like what predictive AI is all about. You have all sort of information in play, you provide that information. The next sentence, say for example, like you want to predict something, or you want the AI to predict something, you give a half sentence, half baked sentence, it can predict the next word. So that's predictive AI all about. And recommendation systems, like you have Netflix, you have Hotstar. So based on all of your patterns of watching, what it does is it in the backend it processes the information and the next best action. Like you saw, you are very much watching a genre of action movies, so the next time it recommends more of an action movies to you. So that's how the recommendation systems would actually work. Autonomous systems, maybe autonomous cars right now like Waymo. It can get information from surrounding environment through images, and also through predefined set of data points that it already has processed. So an autonomous system does not rely on human. Rather, it gets information with the context that it already has stored in. So that's how it actually works. And in deep learning, you have generative AI, which we will be talking shortly. And in generative AI, you don't you not only have large language model, but you also have other models that generate image, generate audio, generate video, generate code. So many of you might have used ChatGPT 4.0 or 5 to generate certain images, right? And you might have used GitHub Copilot, and that's for coding, generating coding, right? And you also used like Agentforce vibes right now. So these are some of the generative concepts. Quickly moving on. The traditional models, I wanted to touch base on traditional machine learning models. Here you can see supervised learning, unsupervised learning, and reinforcement learning. So as said, like we've discussed this earlier, the model will be like trained using labeled data. So based on the reference data, you can group it accordingly, as you can see in classification and regression. So these are some of the concepts within supervised learning. In unsupervised learning, if you don't provide any reference information, it in turn creates a reference, and based on that, it groups it into different clusters, as you can see here. And reinforcement learning, always whenever an AI system performs any action or learns something, the information is passed back to the agent again and again, so that the next time it uses this information as well to give a better response. So that's how it actually works. Through all this, right now we are starting the actual agenda of the session. So introduction to LLM, or the large language model, and its importance. So an LLM can act as an autonomous system, but when? Only when it has an like a machine learning capability. So only when it learns, it can act as a autonomous system. It can design, it can it can be designed to think, to act, and to perform any actions with the help of certain tools. But only when it learns from the external environment and understands the context, it can work autonomously, right? And LLM right now, it does not have any context management system. Rather, it has a certain time period only through which you can perform certain information. Say, for example, you're speaking with your LLM to research about a certain information. Okay, it has a certain time limit only through which you can generate, or you can use that context. But after a certain period of time, it pushes you to create a new chat, right? So that's very much because it does not have any context management system in place. Okay, and unlike simple chatbots, LLM, with the use of a context management system and external memory, it can have reasoning capabilities, and also it can think and act like a human and create a plan, deliver intelligent solutions. So since LLM can get any of your input, a human readable input, right? So any natural language you give it, based on the natural language, based on the input, it identifies the intent, what is the user talking all about, what sort of information that they are requesting, right? So those sorts of information will be available only to LLMs, which additionally has a memory and a context management system. Okay, so as right now, the capabilities are very much increasingly used in customer service, because instead of having simplistic chatbots for predefined configured rules, you can use LLM to talk and make sure that the agent understand what you're looking for. Very good example would be your Agentforce in your case, whenever you create case with Salesforce, right? So instead of us giving all of the information before, right now you can converse with the agent, provide what are the necessary information that you're looking for, so that it clearly depicts what sort of cases is all about. It classifies the case accordingly. And through LLMs, you can create content. So generative AI is really powerful in order to create something from scratch just by a text, a sequence of text, right? And LLM cannot operate on its own, rather with the help of a tool. So when we say an agent will have multiple tools and actions, right? So using these tools, it can perform an end-to-end task without any issues. So we'll be discussing that in the further days. Day 4 or day 5, we'll talk about how an agent would actually work, but the start would be from an LLM. I know everyone would have been very much interested to know about large language model, or at least you have an experience in using large language model, right? But there is another set of concepts here right now that you see in the screen. It's actually starting with LLM. As you know, it's a human readable text. You provide certain information. Based on that information, it is embedded, it is transformed, then it is passed on to the output. Okay, so any text is from a human readable text into a machine readable text. Then after that, you encode that information and you decode it after. So that's how the entire flow works. We'll discuss that in the in few of the slides. But before that, there are other concepts, such as first one is large concept model. So here, instead of consider a model, instead of identifying words that you provide, it understands the overall concept, right? If you provide 2 lines, what LLM does is it identifies each and every word or each and every character in that sentence, and based on that it takes necessary action. But large concept model, what it does is it completely understands what are you actually talking about, what is the intent. So that's how it actually works. This is very much useful because say whenever you use a model to translate something from an English to French or from French to English, right? English works in a different way, but French works in like an entirely different way, right? The characters might be different, the words that you use in the sequence might be different, right? So here large concept model helps the model to be language agnostic. What it does is it completely transforms the text into a concept, a kind of an image in the machine's mind. Then after that, like say for example you want to translate that information into German or into Spanish, what it does is it retranslates back the concept image to the text or to the desirable text. It can be English, it can be German, it can be Spanish. So it's very much easy, right? So here the concept where the inputs are in termed into abstract concepts, it encodes that information into machine readable format, right? Then after that you have something called sonar embedding. It's a really good um, article that you have to read. It's a paper. I'll share that information shortly after this call. So sonar embedding is nothing but sentence level multimodal and language agnostic embedding. So it's an acronym. It's a really interesting concept. You can try to Google it and learn about that one as well. Next, you have large action model. So here comes our agent in play. So LLM, you use your text, but what if you provide certain information, but what if it creates an entire plan and completes the entire process altogether? Say for example, you look for a product online, or you ask your model, hey, I'm looking for this product online. What it does is it looks for the product. Additionally, it creates a plan to identify and compare where does the product is actually having a lower price. And it also has tools in which it can like create an online order for you, and it also can make your payment. So this is a very good concept, a new concept that coming into play. So how it actually does, so whenever you provide a text, it does not look at the text alone, rather it perceives your environment altogether. Okay, and it understands your intent, and using neuro symbolic integration, it's a separate transformer concept. Through that, what it does is it understands what is the end goal of my user. Why is he asking these sorts of questions? Okay, so through these questions, what it does is either it can ask you additional questions, or it can itself make a decision to create an entire plan. Plan may be an example where you use Salesforce Agentforce, where you use RAG, right? So whenever you ask something, it creates a plan. It creates a step-by-step instructions of what to do, what are the next step, what should be done if the task actually fails, what is the workaround. So an entire plan, right? So that's how large action model is also working. Okay, next you have MOE, or member of experts. It's actually a concept of mixing different expert systems into one single system. So as the architecture suggests, you have an input, you have a router mechanism, you have different experts. Then there are series of concepts where you make the human readable information into a machine learning information, and after that you select which of the expert opinion should be used, right? Okay. Moving on. Next, you have a vision language model. So this is also a concept I think many of you might have used. You provide an image. In addition to that, you also provide a text saying, hey, can you alter this image into something else? I require this and this and this. What it does is it encodes the image into human like machine readable information, and also the text as well. Okay, so it's a multimodal concept. Instead of relying only on text, or relying only on image. It combines both image and text, and it can provide you with additional information. And SLM is small language model, very much comparison to large language model, where you use a lot of computational resources, right? So here you use optimized resources. Say for example, an enterprise does not or like cannot offer to use large language, maybe they can go for small language model. The computational resources are less, but the effectiveness is slightly increasing in this one. Next, you have masked language models. These are nothing but text that you provide that are differentiated into tokens, but instead of directly understanding the tokens, what the model does is it masks itself and tries to find out the missing letter or missing character or missing word by looking at the left and the right context. So that's what you see in the screen. By the embedding layer, you look at the right and you look at the left, and it tries to identify or understand like what sort of word that would be. So the last one is your uh, it's actually acronym to SAM. So very much similar to your vision language model, but instead of having image and text separate, what it does is it combines both your image and the prompt together. It does not have different uh, machine readable formats for both prompt and image, rather it's clubbed to one single image. Then using that, it decodes this information and provides the information to the user. So it is also a very good concept. Right now Meta is actually using it, and they're using SAM to an upgraded model for their own enterprise purposes. You can read about that. You also have an article related to it. Until now we saw what are the different models that are currently available in the market and what sort of information that is used to fed into the models, right? We'll go back to the large language model. We'll try to understand how an large language model actually works, right? So here, transformer architecture, this is actually the base. Without understanding how a transformer works, we may not know of how an LLM actually work. Okay. So every transformer would always have an encoder decoder layer, right? It would have a attention mechanism, as you can see in the screen here, and you have a feed forward network. You have a positional encode at the start. Okay. So encoder decoder is mainly to transform any information that you provide into machine readable format, then after that back to the human readable format. Attention mechanism is mainly to understand uh, the word and the word that is relevant to it in the entire sequence. This actually creates a weightage or an importance for every word in a sequence that you provide as a query. Okay. Then feed forward networks would always give you information about what is the relationship between the first word and the next word. Okay. Or in the first word or the last word. So that's how feed forward network would actually work. As you can see here, feed forward network would provide this information to the next attention mechanism that you can see in the screen. Positional encoding, it's nothing but whenever you provide a sentence, each and every word would have a certain position to it. So that information is added here, and this is also in count to understand the intent specifically. Okay. The transformer would expect certain information, but in order to provide that information, us we give a certain query. It can be too large of a sentence, or it can be too small of a word, right? You can give one word, or you can give two, or you can give a paragraph. Anything is possible in LLMs, right? But how does it actually get that information? How does it understands that information? So the first part where the tokenization comes into play. Whatever you provide, that tokenizes that information into different segments or different sequences or tokens as such. Okay. So on the right, the image would clearly identify this is an entire paragraph, but what the LLM or the AI system does is it tokenizes based on the words, as you can see here. So the overall paragraph is this entire paragraph that you can see in the screen. LLM, it created a 94 sequence which has a different colors to it, as you can see here. Point to note is that never is repeated many times, but everything is like a different token altogether because it's repetitive, right? And gonna is also repetitive, as you can see in the screen. Okay, even though there are like 382 characters, the tokens right now are based on word level, so that's why you have 94 tokens. So differentiation in tokens are, you have word level token, subword level token, and character level token. As the name suggests, any query or any sentence that a user provides, it splits into complete words that you can see here. So that is word level token. Subword, it's based on certain subwords. If stranger, you can, or the AI system will break it into two, right? Just for more context. And character level is something that you create an entire label for each and every character that you see in the screen. W is one character, E is one character, apostrophe is one character, so on and so forth, right? So each character is treated as an individual token. So what happens in a word level token? So it's very simple, right? But it creates a large vocabulary. Say for example, here as you can see, it creates a 94 tokens. Even though never is repeated 7 times, every word called never is a separate token for it, right? And in terms of character level, you can create different characters for an alphabet, but it has a small vocabulary size, right? And whenever you do some computation in the backend, it takes an additional computation information because there are 382 characters. Comparatively, for 94 to compute it, here you have 382 characters that had to be fed in and understand like what part of sentence it actually is. And you also have to compare it with the next word and the before word to understand its context and the intent, right? Subword is the optimal level that the enterprise are actually leaning towards. It can break into meaningful chunks, has a balanced vocabulary. It can also handle rare words in any language. It's actually used in many of the large language models right now in comparative to your word level and character level tokenization. So since we've talked about more theoretical information, I wanted to give you a demo of how a transformer would actually work. So maybe I'll go through each and everything step by step. So first we've talked about embedding, right? So at the top, you can see a sentence called data visualization empowers user to visualize. Okay. Each and every information or the tokens are added into the embedding mechanism, as you can see here. Sorry. What it does is it positionally encodes. So data comes first, so the position is 0. Visualization is second, so the position is 1. So this is how the positional encoding would work. So apart from the token embedding, you can also add positional encoding to provide additional context of where does the word fit in this entire sequence, right? And after that, like once your embedding or the information is turned to a vector, what happens is there comes an attention mechanism. As discussed, attention mechanism is something that it identifies a certain keyword and creates a vector for the near keyword and the farther keyword. So this is how everything are like computational through mathematical formulas. I'll give you formulas also after this call. This is actually a visual representation of how an entire transformer would work. So once attention mechanism is completed, what it does is it creates a key, query, and value. Query is something the data that is focused on. Say for example, you want to understand the relationship between data and visualization in this sentence. What it does is data is the first word, visualization is the key. It multiplies this one or the query and the key, it creates a dot product, then it scales it to -3 to +3. Okay, then it soft maxes or it creates a probability from 0 to 1 or from 0% to 100%. So that's how this actually works from a step-by-step approach. You also have calculations for each and everything in the background, but this is just a visual representation, right? Then at last, what you do is you calculate or you multiply key query pairs with the value. So here in this transformer, what it actually does is it predicts what is the next word. Maybe I'll give a different one. Artificial intelligence is transforming the lives. So based on the temperature and the sampling, lives is the best word for it to predict. You can have like multiple iterations of generating each and every next word predictions. I can give you this transformer explainer as well. You can play around it. You can identify what sort of next predictions that it can make. The possibilities are endless. I can give another a sentence called like Agentforce helps. Then I generate what would be the next word for it. So what it does is it breaks Agentforce into agent and force as a separate token. Then it generated or predicted two would be the next keyword. Then after that, it predicted keep would be the next keyword. Then the is the next keyword. So you can keep on predicting it up to 12 variables or 12 tokens. Okay, so you can play around it. It's just for computational purpose, just to understand like how it actually works. You can play around the temperature, you can play around the sampling and understand. As you know, temperature, when you increase the temperature, it increases the creativity. So probabilities will come to one single space where higher probability alone would not be picked, rather any probability in this entire spectrum would actually be picked. So it's interesting actually to learn. So please do so. And yeah, so we keep on talking about like what is attention mechanism, or what is how do you actually understand or predict what is the next keyword, right? So you need to understand the context of the query that you provide. Say for example, I need some information from so and so website. Okay, so attention mechanism, what it does is it creates a set of query key and values. Query key are the pairs, as you can see here, and the types in which the attention mechanism would actually work is you have self attention, multi-head attention, and cross attention. But the overall architecture or the overall processing would be very similar. So you create a query, and based on the query you also have keys in which you have to multiply it. So each and every token would attend to every other token in the sequence. My name is Vignesh. When you say like that, my will be attended as a self attention mechanism. It starts with my, then the next word in this entire sequence is name is Vignesh, right? It looks for the relationship between my and name, my and is, and my and Vignesh. Then what it does is it repeats again for name. It looks for name and my, name and is, and name and Vignesh. So what it does is it creates a complex pattern of relationship, right? And through that only it identifies which keyword is better suited or better related with which keyword, right? So that's attention mechanism all. At the last, we have sampling technique. So right now, we've talked about transformer architecture. How does a transformer architecture actually work on a high level in a theoretical format? But at the end, you need to understand how does a text gets generated, right? So through series of sampling techniques, you can use generative AI to create text or to generate text. So in the transformer explainer that we recently saw, you can see like how it actually works or what sort of information that it actually provides, right? So the next probable keyword or the next probable keyword in this entire sentence based on the attention mechanism. So some of the sampling techniques could be deterministic methods such as your greedy decoding or greedy search, beam search. So it does not look for probabilities exactly. What it does is it looks for the entire text and it creates a text altogether. A next best word for that entire sequence. So that's how deterministic methods would actually look. In terms of stochastic methods such as top kappa sampling or top row sampling, what it does is it reduces the randomness. The probabilities are slightly reduced, where anything or any relevant keyword can come into play. The creative mindset here, whenever you use top kappa sampling, it creates an endless possibilities of what could be the next step. Say for example, my name is Vignesh and I work. Then what happens is work, when you say something called work, when you use sampling method of top kappa sampling, work in any specific organization or work in any specific stream, or I'm working in this specific location, or I'm working. Those sorts of high possibilities would be possible only when you use this stochastic methods of sampling techniques. At the last, you have temperature parameter. I think many of you would have used this temperature parameter in your LLM. So low temperature, you say the model to only look for specific information, and only with the information you create something. But when you increase the temperature, you in turn say to the model that it's your own creativity, you can do anything you want, but I need certain information based on what I ask. So whenever you increase the temperature, LLMs become highly creative, and they'll create multiple sequences of text, whichever that does not even references to whatever you asked before. So that's how creative it is. Okay, I think we are at the end of our session today. To summarize like what we have learned or like what we have gone through as a group. So we've talked about what is artificial intelligence, how does it work, what are the components in artificial intelligence, subsets of artificial intelligence are the concepts altogether, traditional models of machine learning, upcoming AI models used currently, transformer architecture, tokenization, attention mechanism, and sampling techniques for text generation. Okay. So in the next series or in the next session, we'll be talking more about types of large language model, how an LLM are invoked, what is a prompt, what are the types of prompt, how can you engineer a prompt from scratch, and introduction of AI to Salesforce. Okay, I'll stop right here. Please free to drop your questions in the chat. I'll happy to answer. If your question is not answered today, I'll make sure that it is answered by end of this series. And thank you so much, everyone, for taking your time in order to attend this session.